Does anybody remember how we talk about or how we call special polynomials that look like 1 or 2? There's a special name for it, and there's a special formula for it too that if we can remember, it'll make factoring ones like 1 and 2 faster. The answer does have a negative and a positive because the last term is negative. The sign thing must change. Okay, pause. Go back in 7-7. Go back in 7-7. There's a special name.
Perfect square?
Difference of 2 squares.
Difference of 2 squares.
Difference between 2 squares. The difference of 2 squares, the difference between 2 squares. Okay? Now, Jay is saying, like, hey, the signs are opposite, the signs change. And the numbers will match or the numbers will be the same. Now, hold on. He's throwing a lot of information at it. So far, we've heard 1 positive, 1 negative. We've heard 12 is an important number. Why is 12 important for 144? Good. 12 squared is 144. 12 times 12 is 144.
X minus 12, X plus 1.
What's missing? What's missing that makes these two special? What's missing from all the other types we've been seeing? The middle term is gone, which means it canceled. And in order for the middle term to cancel, Rob, what did you say the answer was?
X minus 12, X minus 12, or X minus 12.
Why would the middle term cancel when we FOIL something like x plus 12 and x minus 12? One's negative and one's positive, and what's true about the outer and the inner? That would be? Outer would be? Negative 12x, inner would be? So what's negative 12x plus 12x? 0. That's going to happen every time. They look exactly the same, but the signs are opposite. So in order to factor a difference of squares, in order to factor a difference, a subtraction of squares, we can always figure out the square root of the first. That'll go first in each of my factors. The square root of the last, that'll go last in each of my factors. I can always double check by FOILing, but we get to shortcut the process if we can learn how to get there properly. Yeah. Which means number 2 can be a really fast factoring problem also, as long as we see it's a difference of 2 squares. That's a little bit harder to see though. For number 2, can you guys tell? For the first term, how can we rewrite this as a difference of 2 squares? 4. Now, if you guys are wondering why I'm rewriting it like this is actually kind of how our notes did it. We said a squared and b squared, so we could say x is being squared for the first step here, 12 is being squared for the second, and we used x and 12 in our factors.
Did you say bu squared?
Back in our notes, can I turn there? Oh, not my iPad yet. Hold on. We used a and b, a squared and b squared. Let me see if I can go back there really fast. There we go. So at the beginning of 7-7, here it is. We used a squared minus b squared. So I was trying to show you, once we see that x was squared minus 12 was squared, we can jump to the answer, and we'll do the same thing for the second example. So let's go back to our warm-up real fast. There we go. Guys, since I had to switch my notes, help me out real fast. Can you help me out? What were the factors just real fast for number 1? The entire factor.
X minus.
It doesn't matter if it was plus and then minus? Good. Doesn't matter if it's multiplication is commutative. Okay, number 2. We were just talking about who was squared to get 16, x squared, and who was squared to get 81.
Mine.
Now, you don't necessarily need to show this work every time, but you do need to figure out who was being squared. So if x was squared up here, and 12 was squared up here, and that was my answer. Jordan, what would be my answer for number 2? Close. Use what you see. Who's squared? Yeah, you're trying to square root again. There you go. So then you would have 4m, keep going. Good. This was homework number 34. This was homework 7-7, part 1. Looking at a difference of 2 squares and saying, hey, there's a shortcut for factoring that. Do we like shortcuts if we can use them properly? Do we like them if they make all our problems wrong? No.
X plus 7 squared.
So we have to make sure that we understand the pattern. Now, this is the pattern for the difference of 2 squared, 7, 7, part 1. Homework 35, Caleb. Homework 35 was 7, 7, part 2. And that was how to factor the difference of perfect squares. This was Friday's section. Now, I've already heard one person say, like, hey, I know the answer for number 3, and that's awesome. But my question to you is, for those of you that don't know it right away, right off the bat, how do I factor x squared plus 14x plus 49?
The chart.
I can do the chart. That's true. I can do the chart. What happens when I do the chart? Don't I have factors of 49 because there's no number in front? And are I trying to think of what they sum to be? Some of you are like 7 and 7. Yeah, what's 7 times 7? 49. Now what's 7 plus 7?
14.
I was right then.
So what are my factors?
X plus 7, X minus 7.
Caleb, what are my factors?
Oh, X plus 7, X plus 7.
Oh, wait. That makes me 7 because that's 49.
Yeah. So 7 and 7 work well, so then Caleb just put it in the answer form. How do I use that 7 and 7 word? I need an x plus 7. Okay, what's the second one? Careful. If it was minus 7, it would look like the one above.
It's a plus.
Ms. D, I have a question.
Hold on, Rob. Hold on. Raise your hand and wait. If the last sign is positive, look at the front. Don't look at me. The last sign is positive. The signs are the
Same.
okay. Double check. Make sure. The first term is 1. Yeah, and 1 times 1 is the only way to get it. So 1x and 1x comes to start with that. Oh, we didn't do the long version of the table. We did the short version of the table. The long version of the table would have been factors of x squared, then 49, then the possible. But the only way to make x squared is 1x times 1x, and this one we showed 7 and 7. Does that make sense? There you go. Rob, what was your question?
Okay, can you make it X plus 7 squared? Is that also an answer?
Yes.
Would it mean the same thing?
Yeah, because
Yeah. Rob is asking, is there another way to write the answer? And if you guys were checking those answers in your book, you should know yes, right?
No, but let's say like it was like that problem. Can we put either one?
Caleb, Dylan, what's going on? I want to start talking about personal grades and how we need to be focused on. Let's focus and let's learn. We have a test on Friday.
Like let's say 1 plus like X plus 7 squared, so that it mean the same thing as X plus 7, X plus 7.
Either one works, right?
Yes.
Both are just as appropriate. I'm just saying for the entire class, your warning has been dealt over and over again today. The next one that's distracting, very careful. Straight to Mr. Kim. I don't care. I'm trying to teach, and if you're not going to allow the rest of your class to focus and to learn, you're hurting yourself and you're hurting them, and I have to protect them, so I have to send you out. It is what it is. That's only fair, right, Alan? It's only fair. You had to put up with it. And some of you guys were the ones that were distracting him. It's your turn next. I'm more than ready. Okay. That was number 3, factoring x plus 7 times x plus 7, which is x plus 7 squared. The additive counts. Let's fix our attitudes and let's focus in. I believe coaches would be mad at bad attitudes. Rob, go ahead.
Let's say we also number 1, how it says X minus 12 and X plus 12. Is there anything we could do for like condition number 3?
Well, the problem is, what's the difference between the form or what we're
They both
factoring?
have
Number.
plus and we do 1 and 1 has minus.
This one has both positive.
Now
The
if they were
last
both
sign-
minus, I could do that. Or it has to be plus.
Well, it wouldn't look like this though. Remember, whenever you have a difference of 2 squares, there has to be one in each. Now, number 4, guys, is a harder one like the homework due today. Johnny, I told you the same thing. Doesn't number 4 look a lot harder than number 3?
Yeah.
Right? I think so.
Yeah.
But number 4 and number 3 are so stinking similar. And here's the reason why. even though there is a number in front, and even though we don't like that number in front, because it makes us do the long table. If we do the long table, we look at our 9y squared, right? We look at our 25, right? Thinking about our possible. To try to figure out which one matches the outer and inner, which is our middle. We're trying to make this match. Okay? This doesn't always happen, but it's definitely worth trying. Is 9 a perfect square? Yeah.
Yeah.
2 times 2 is 9.
3.
Okay, so let's try 3y and 3y, and is 25 a perfect square?
Yes.
5 times 5. Let's try it. Now, hold on. If the last sign is positive, the signs are the... Look at the middle, negative. Okay, good. So we have a negative 5 and a negative 5. We can try those possible. 3y minus 5
Negative.
times 3y minus 5. Good. A negative times a negative is a positive, which is why this is a positive 25.
15 and 15.
And some of you that have been working on this trick, 3 times 5 is going to be 15. 2 of those 15s is going to make 30. The trick works. But you can also think of, just multiply your outer, right? Your outer 2. 3y times negative 5 is negative 15y. And then we have to do inner, right? Negative 5 and 3y. Another negative 15y. So what's negative 15y plus negative 15y?
No, no.
We got it.
You say times or plus?
Negative 15y plus negative 15y would be negative 31. So even if there are nasty numbers in front, if they're both perfect squares, try it. Maybe it's the exact same thing like this one is going to be. See it? They're going to end up being the same. And Rob, don't say anything this time. Does anybody remember the shortcut way of writing if they're the exact same? This is a good answer. I'm boxing it, but there is another way of writing it. Yeah, Kaylee's saying it, a lot of you other ones are saying it too. Good. 3y minus 5 quantity. Either way of writing it is just as good in my book. So, is there a shortcut? I don't even like the word shortcut. Is there a way of remembering perfect squares? Yes, but I would just say if you see a perfect square, try that first. See if it works. Sometimes it will, sometimes it won't.
Why don't you say like the last sign is negative, signs stay the same?
If the last sign is positive.
Yeah. Oh, I meant positive and
Yeah.
stay the same. Then why did you change that up?
Oh. It was negative 15y and negative 15y. Some people get confused and think that's 0, so I was reminding that negative 15y minus is adding a negative. So there's technically a plus and a minus there. I think the plus just got a little too close, and it looks like it's a plus. There, is that better?
Yeah.
Good. So negative 15y plus negative 15y. Okay. Kiddos, this is what homework was on over the weekend. Thursday night's homework, Friday night's homework was on these 2 big ideas. Which ones of these do we like because it's shorter as long as we can do it right?
The first one.
First one and the second one. We can go straight to the answer. The first one's like the easiest because there's no number in front. Second one's a little bit harder, but we can still shortcut to the end, right? But some of you, these ones aren't bad either, as long as we remember the process, okay? Now, with that, let's go ahead and check our evens quickly. So homework out. Homework out. Everything from page 401 that you have should be homework 34, 35.
I'll have my 35 tomorrow. I forgot that. Okay. So I'll have 36 and 35 tomorrow.
What page was this?
Page 401.
Okay, what's the question on the number?
Don't worry, we're gonna check. This is homeworks 34 and 35. Everything from page 401, that was Thursday, Friday. That was Thursday, Friday. Now, wait. Do you guys see how this is what we were doing?
Yeah.
Now, it starts getting weird right about there, right?
Yes.
But 4 and 6 and 8, which would have gotten you 3 through 10, I think?
3 through
Maybe
14.
3 through 9.
No, 2 through 14.
Oh, well, they should be in the order of what you guys did, but let me go ahead and see if I can. There we go. Is that a little better? 4, 6, 8.
Shouldn't 2 be there?
Was it not 3 through? Was it 2 through?
It was
Okay. Sorry guys, I messed up. There's number 2.
Oh,
Number 2, you guys might have gotten a little stuck on because it was actually asking you to find the one that doesn't match, right? Yeah, there were 2 binomials and 2 trinomials. I bet we'll come back and we'll talk about number 2.
number 2 is
Hmm?
Wait, which number is this? Or
This is
homework?
homework 34 and 35. Everything's on page 401.
Okay, I have 34.
Okay. So this beginning is 34, 2 through, was it 14?
14.
2 through 14, and then the second half is going to be our perfect square one that you guys saw us. Now remember, you could have done p plus 15 times p plus 15. I don't know. Just as good. You could have written them next to each other. They did the shortcut version, writing the squared instead. We'll come back to number 2. I know you guys might have a question on that one, but are there other ones you have questions on? Josh,
12 and 14.
12 and 14. What else do we have out there, kiddos?
And if you can, 10.
Let me scroll down too so you guys can keep checking. That's all the way to number 30. Ron,
I'd like 21, please.
21?
Yeah.
Okay. Is that a harder one? Anything else? 23. 23? As we get started to go over these questions, let me go ahead and first of all zoom in on number 2. On number 2, kiddos, we were supposed to figure out which one does not belong. Another question?
Yeah, because I wasn't here on Friday, what was the one you had to do?
Oh, homework for Friday was numbers 15, keep me honest guys, 15 through
It was
24.
27, 24, and 27.
Wait, what was number 34?
Are you sure? You right, I was-
2:14. But I thought it was like 3:14. It was 2. I thought it was 3:14.
What oh, 35 is,
I thought it was 35. 15.
Jack. You technically have as many days as your absent. Make up for it. You just write that little absent label and then we double check with it. Alright, kiddos. For number 2, it was weird. And I gave it to you on purpose because there's a very, 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 very common mistake that kids make in factoring. There were 2 binomials. You're supposed to figure out which one doesn't belong. There were 2 binomials and 2 trinomials. So that wasn't the pattern that they were trying to say didn't belong. 3 of these have something in common, and one of them is left out.
Yeah, I thought it was 50.
Some people might have thought the first one, because the other ones have pluses, that's actually not the right pattern. Some people thought binomial, trinomial, but there's 2 and 2, that's not the right pattern.
it's k squared plus.
The right pattern is, ready? This one, didn't we learn in the warm-up we can factor that? What would it be?
And minus 4.
Careful, n minus square root,
N plus
2.
2. Oh.
This one factors, right? This next one, he would have been like one of the small table ones, factors of 9 that add to be 6. I think that's 3 and 3, right? But hold on, the last sign is positive, the signs stay the which sign? Yeah, we need negatives in there. So we have that negative in the middle. This one factors. Wait a minute. Doesn't this one factor also? Factors of 36 that make 12.
Okay, 6.
6 and 6? But what sign? Signs stay the same. What sign? Positive, positive. This one factors, this one factors, this one factors, this one.
Factors.
What would the factors be for k
K
squared?
and 5.
Okay, if it was k plus 5.
Oh, because there has to be a negative.
Oh,
It has
the
to be a
negative, right.
What do you guys think? If we do k plus 5, k minus 5,
Because then that would be k squared plus
that's going to have a
10.
minus.
There's no middle, yeah.
If I did k plus 5 times k plus 5, now, Some of you would be killing this poor little puppy right here. You'd be shortcutting, saying it's k squared plus 25. But
Don't kill the book.
it's k squared plus 5k plus 5k, which ends up being plus 10k. Does this match the one up there? No. Does that match the one up there? No? Okay, it must be k minus 5 times k minus 5. But guys, the sad thing is, this also has a middle term.
Don't finish it, you kill the book.
Do either of these match k squared plus 25?
Now you just killed my book.
Here's the crazy. He can't be factored. It's impossible. There's nothing you can do to factor him. He is an illegal function in terms of factoring. He is an illegal function. He's the one that doesn't. Now the rest of you guys' questions come from 10 through 14 and then 21 and 23. So let's go ahead and check those out. The answers have been up more than long enough for you guys to check them. Let's go figure out what's going on in 10 through 14.
But you said we were going to go over
10 through 14.
They were a little weird. Why were they a little weird though?
No, number 21.
Oh. I was confused.
Okay, question. What was different about the numbers that were in 10 through 14?
It had square.
They had squares, but what didn't they
They
have?
didn't have no like X or Y.
Yeah, where were the variables, huh?
They didn't compare.
No X's, no Y's, no M's, no G's, no Q's.
Don't you?
So how are we supposed to do it when there are no variables? And the answer is exactly the same. But how exactly the same? Yeah. Jackson, what do you think? That's okay. Exactly the same. Don't we have difference in two squares again? Jordan, help us out. What would the factors be for number 10? It's weird. Pretend like there are variables. Pretend like there are variables. Jackson, you want to try number 10? I'll go back to 10.
I just did 19 minus 11, and then 19 plus 11.
Oh, dang it.
Oh yeah, that's what it was.
Difference of two squares, right? Just we do it with numbers instead of with variables. Now, what's different on these ones? I think, Josh, this is the one that you were asking about.
Yes.
If we're able to factor using the plus minus technique and then the two perfect squares, the square roots of those, can't we do 19 minus 11?
Yeah.
Parentheses, what is 19 minus 11?
Yeah.
8. What's 19 plus 11? Sorry, quick mental math, 30. But you end up with your final answer, 2. Solve it a different way without having to square these numbers, which would be, I don't know, a lot of mental math.
Oh, so the numbers that you multiply are the answers.
Come out of the parentheses.
Oh, I did it. Oh,
See? So you factor first, and then you do the parentheses, and then you just multiply together.
I did it. So.
Yeah.
Why aren't they both negative? Because there's only one sign.
True. But remember, if they were both negative, if the sign stayed the same, that term should have been positive. The last term is positive, they stay the same. The last term is negative, they should. You can also think of the outer inner cancel. Perfect. I thought someone just went out.
Rob is back.
Jackson. Yeah. Keep going, Jackson.
I did 54 plus 52, 54 minus 52.
Here's a good example, kiddos, of does it matter whether you plus or minus first?
No.
Ugh, that would be such a hard problem to do.
No.
What's 54 plus 52?
106.
What's 54 minus 52? Oh.
2.
Oh yeah, I can't even multiply. It's 212, isn't it? Mental math sometimes goes too quickly. I think you guys had the idea on 10 through 14. But you also had questions on 21 and 23. So let's go check those out real fast. Let's get ready to turn in our homework. 21 through 23 was over here, huh? 21! So close to our warm-up problem. So close to our warm-up problem. Question. If we're thinking about 25n squared, and we're thinking about 4, maybe before we start doing all of our possible factors and all that jazz, is he a perfect square? Yeah. Let's try 5n and 5n.
Oh yeah.
Is he a perfect square? Let's try 2 and 2. And guess what ends up happening? It works. Is that a good way of writing it?
Yeah.
Could you also write it 5n plus 2 quantity, the whole thing squared?
Yep.
Yeah. Both are good. Both are good. Number 23, what was the mistake?
Should have used square, different square patterns.
Yeah, we need to use the difference of square formula that we saw from the beginning of class. The difference of square formula says, how do I take that? How do I factor that? When the last sign is negative, the signs they must. So who's going to be in here?
21.
They got the formula wrong. Kiddos, homeworks 34 and 35. I want you to go ahead and just pass straight back to me on it. Who's going to do them for us? Whatever you have come before absent, make sure to write absent when you turn it out homework tomorrow. We need to go back to our notes. Yes, please. All right. This is the one thing we need to cover today. We don't have a lot of time. We did get a lot of reviewing done.
Yes.
We did get a lot of reviewing done. All right. Word for word. Let's go.
This is 5, 8, 7, 8.
Yeah, this is 7, 8. Thank you for checking, Dylan. My people that were absent. You guys need correction papers.
I saw some. Wait, am I?
7.8 is what we're doing right now. Everyone should have their quizzes now. I gotta ask the people that were absent. Alright. I know it's warm in here, guys. Hang in there. Sometimes the air takes a little bit longer than I would like. Yeah.
What
Just all disappeared. I know. Shock. It's back.
Shock.
Okay. We're gonna go ahead and zoom in. Sometimes binomials can be shared or in common also. Binomials. Hold on, GCS, that's always only been monomials. It's always been like a number maybe multiplied with a letter, but it's always been monomials, right? What's this whole binomial shared thingamabob? It's like a GCF, but it's bigger. When we see polynomials with 4 different terms, when we see polynomials, is there a special name for that? 4 different terms?
Quattro.
Yeah, not really. There's trinomial, then we just say polynomial. If we see a polynomial with 4 different terms and none of them can go together, there's a special thing called grouping. Now, this isn't always going to work, especially when we get into something crazy like algebra 2. Sometimes they get hard and they have 4 terms. But you can do it another way. But whenever you see 4 terms, the very, very first thing you ever want to try is, if I look at them in pairs, this is called grouping. If I look at them in pairs, could I pull out anything common from the pairs? Maybe not the whole thing, but the pairs. Now, careful, this is a plus, this is not a times. I did not just make my answer. All I did is split them up in pairs. When you look at the first pair, which means the first 2, and if I were to zoom in on them for just a second, I know, but question, what is in common between those 2
The
terms?
X.
How many x's though?
Uno.
X squared, right? Okay.
Or X cubed.
There is an x squared
No, I was just
in
saying.
common. The question is, what is left when you divide away the x squared from x cubed? There's 1 x left, and then
X
didn't we
plus
take
3.
all of his x's? So
I get it.
all that's
plus
left
3.
is just the 3.
Oh.
I'm factoring out the GCF. X squared away from x cubed, x is left. X squared away from 3, x squared at 3 is left. Okay. I looked at the first pair, now it's time for me to put a plus. Now it's time for me to look at the second pair. What's in common in the second pair?
2.
Now remember, we divide.
So that's x plus 3.
2x divided away 2 is just x. 6 divided away 2 is just 3. Now wait. What do you guys notice is now in common for both of them?
X plus 3.
So here's what we're going to do. You ready?
Yes.
The same way that x squared was in common, the same way that 2 was in common, now that I see that x plus 3 is in common, it's going to start looking really weird. Hang in there and write it with me. We're going to say we're pulling x plus 3 out. The same way we pull out a 2 and we pull out an x squared, we're pulling out the x plus 3. What is left when we take out, divide away the x plus 3?
X squared plus 2.
Why? Because this one's an illegal one to factor, and that one, there's no squared or anything he's done. Tyler.
Okay, so I have 2 questions. So, the way you get x squared parentheses x plus 3 and then 2 squared or 2 parentheses x plus 3. You just find the common factor
Hold on, pause for a
in
minute.
both the parentheses.
What's in common for this one to pull out? What's in now I put the parentheses in, but that's what grouping says. There's 4 pieces. It's too big. Cut it down. So what am I going to do in letter B?
Yeah.
What am I going to do in letter B? I'm going to put some parentheses and say, hey, is anything shared? I'm grouping in pairs and asking if anything is shared. Now, there's something shared there. There's nothing shared there though. I'm going to get messed up. But what you can say is check to see if there's anything shared. And if there's not anything shared in both, we can, because it's addition, we can rearrange. And my question is, why is it helpful to rearrange?
Because it helps you to do it.
Sometimes.
Yeah.
Now is there something shared in both? Yeah, what's shared in this one?
X.
So we tried grouping the first 2 pairs. It wasn't quite good enough, but now that we're trying to group again, is there anything shared here?
Y.
Why?
Now it's going to look a little funny, but isn't x plus 1 the same thing as 1 plus x? So I can take a quick step and rearrange it to be x plus 1. Now I can say, what's shared?
X plus 1.
So we're going to pull the x plus 1 out, and we're going to say, who is left?
X plus Y.
X is left. When I pull that, x plus 1 out, and y is left. Now, kiddos, tonight's homework is just 3 through 10. It only has to do with, don't worry, that was all extra. It's not in homework that I just skipped. 3 through 10. Homework for tomorrow, we're turning in tomorrow. Just see if you can figure out grouping, looking in pairs. Bye guys, I'll see you later.
Oh.